Morning students, in this session I am going to discuss the types of enthalpy. Few of types of enthalpy we have discussed in the previous video. Rest of the types of enthalpy today I will discuss. So note down the types of enthalpy. So our number 10 types of enthalpy is enthalpy of solution. Enthalpy of solution. What is enthalpy of solution? So let's discuss. Write down the definitions. The heat change for 1 mole of solid converted into its aqueous form For example, sodium chloride solid state, when dissolved in water which is in liquid state, the formation of sodium aqueous plus chloride aqueous. This is known as enthalpy of solution. Solution is XYZ, maybe kilojoule per mole. This is called the enthalpy of solution. So we symbolize it by del solution enthalpy. Next we discuss enthalpy of hydration. Enthalpy of hydration. Students, all the definitions will be used when we study about the S block element, P block elements. So here we discuss the enthalpy of hydration, which is useful for our next chapter also. So what is enthalpy of hydration? So del hydration enthalpy. The heat change for 1 mole of gaseous ion. The heat change for 1 mole of gaseous ion convert into aqueous. Heat change from 1 mole of gaseous ions convert into aqueous state. Suppose we have sodium ions, means vapors form, plus then dissolve in H2O. So we have sodium ion aqueous, and the heat release is known as del hydration is suppose XYZ kilojoule per mole. Similarly, we have chloride ion, which is also in a gaseous form, dissolve in H2O, so it will form chloride aqueous, and del hydration is Y kilojoule per mole. So this is the enthalpy of hydration. The heat changes for 1 mole of gaseous ion convert into aqueous state. Now next, next is enthalpy of neutralization. So write down the definition. Enthalpy of neutralization. The heat change for 1 mole of hydrogen ions completely neutralized by OH ion called enthalpy of neutralization. For example, sodium hydroxide treated with hydrochloric acid, it will form sodium chloride and H2O. This is the best example for neutralization reaction. So del neutralize is minus 57.1 kilojoule per mole. So this is the heat of enthalpy of neutralization. We discuss the ionization enthalpy. Next one is ionization enthalpy. Del I H, ionization enthalpy. The minimum energy required to remove an electron from outermost orbit in gaseous isolated atom. Is called isolated system, or we can say that gaseous isolated system. Best way to express isolated system. So sodium converted into gaseous form after sublimation process, it forms sodium ion and 1 electron removed. So ionization enthalpy is plus x kilojoule per mole. Plus sign because energy is used to remove electron from the sodium atom. Next is the electron gain enthalpy. Electron gain enthalpy. electron gas. The heat changes to an electron to add an electron in gaseous isolated system. Suppose fluorine gaseous form, when take electron changes into F negative gaseous. So electron gain enthalpy is joule per mole. So when electron is added, amount of energy released when electron is added to the isolated gaseous system. This is known as a electron gain enthalpy. Next, thermodynamical equation. Thermodynamical equation. When the chemical reaction represented with state of reactant and product with heat change called thermodynamic equation, called thermodynamical equation. Simply, for example, carbon solid state, oxygen gaseous state, it forms CO2 gaseous state. So enthalpy equal to minus 393.5 kilojoule per mole. They follow three rules. They follow three rules. First, if the reaction will be reversed, then the magnitude of enthalpy will be same. But the sign will be reversed. Suppose carbon dioxide gas, carbon solid and oxygen gas, then sign will be reversed. This plus 393.5 kilojoule per mole. Here we use minus, here we use plus. Only the magnitude of enthalpy will be same, but the sign will be reversed. Next tool is the If the reaction will be doubled, then the magnitude of enthalpy will be also doubled. For example, we take 2 moles of carbon and 2 moles of oxygen. This is gaseous state and this is the solid state. So, formation of 2 molecules of carbon dioxide. So, del H 2 into minus 393.5 kilojoule per mole. This is the second rule. Now, third rule is if the reaction will be half, then its magnitude will also be half. Half carbon, half oxygen, formation of half CO2 gas. So it also becomes half kilojoule per mole. Now next is the Hess law. What is Hess law? According to this law, the heat changes for any chemical reaction. The heat changes for any chemical reaction present in single state chemical reaction is equal to sum of heat change in several states to find similar product. Suppose A changes to B, Q2 heat taken, B changes into P, so Q3, and suppose R changes into A, suppose this is R, this is changes into A, so Q1 heat, A changes into B, Q2 heat, B changes into P, Q3, and R changes into P. Suppose this is Q. So Q is equal to Q1 plus Q2 plus Q3. So heat changes for any chemical present in single step is equal to sum of heat changes into several steps to find similar product. For example, carbon, oxygen get converted to CO2. Del H is minus 393.5 kilojoule. Suppose this carbon, if we use half O2 converted into carbon monoxide, here del H equal to minus del H equal to minus 110 kilojoule. Suppose this amount of energy release, and this carbon monoxide again changes CO2 when it take excess of O2. So del H equal to minus 283.5 kilojoule. So sum of this is equal to this. This is called the Hess law. So it is important term also, students. So learn the Hess law. So that's enough for today, students. Next topic we'll discuss in the next video, like calorimetry and another or important property like entropy or spontaneity, or next what will be the topic given in your chapter. So that's enough for today. Thank you.